Welcome again, wonderful Wildcats, to another wonderful Wildcat Radical lesson. So today we're looking at Monday, solving radical equations. And that's going to be on journal page 30. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at your notes. All right, solving radical equations. Steps to solve radical equations. Step 1, isolate the radical. Step 2, raise both sides of the equation to the power equal to the index of the radical. Step 3, solve for the variable. And in doing that, you're either going to simplify, use the box method FOIL, or factor. Step 4, check your answer or answers. All right, if you would, finish up your notes. All right, now your notes are finished. Let's take a look at the examples. All right, solve the radical equations below. All right, so we want to have our notes next to us as we go. So step 1, isolate the radical. So to do that in example 1, we're going to divide both sides by 2. But before we continue in the example, I've noticed something when y'all's work is unorganized. And one of the things about math is the organization is helpful. So what we're going to do when solving now is let's add lines to help organize our work. So you'll notice I'm using a flexi ruler. If you don't have one of those, use another ruler. But your chance, go to HEB and get a flexi ruler because they're flexi and amazing. And they come in Wildcat Blue. Now your lines don't have to be evenly spaced. Now if you want, you could. I'm going to go back and straighten that line out because that just doesn't look very good. All right. So this should help you organize your work, okay? All right. So the first step is we're going to divide both sides by 2. So 2 divided by 2 is 1, and 14 divided by 2 is 7. So you get the square root of x plus 1 equals 7. All right, now step 2 says to raise both sides of the equation to the power equal to the index of the radical. So the index of the radical here in this case is 2. So we're going to raise both sides by 2. All right. So when we say the square root of x plus 1, that's the same as x plus 1 raised to the 1/2. So when we square that, we're really multiplying the 1/2 by 2. Well, 1/2 times 2 is 2 divided by 2. 2 divided by 2 is 1. X plus 1 raised to the power of 1 is just x plus 1. And then 7 squared is 49. Now, I'm only going to do this in example 1 where I write out the x plus 1 to the 1/2. Just know that if you raise an index to the same power, they combine to be the power of 1. So in essence, the square root goes away, or the cube root of the fourth root. Okay, this isn't canceling. This is basically becoming to the power of 1. All right. Now, last step, subtract 1 by both sides. X equals 48. All right, and then step 4 is check your answer. Now, a little advice as we're working through examples. I'm going to work through every example for the students that they see it, they're good, they move on to the assignment. But if you get stuck on a problem, at the point you get stuck, I would recommend stop, don't write anymore, and then come to class, and then you can ask me that question. I can help you finish the example, okay? All right, so to check, you take the number, substitute it in for x, so that's 2 times the square root of 48 plus 1 equals 14. Well, 48 plus 1 is 49, so that's 2 times the square root of 49. 14. The square root of 49 is 7, so 2 times 7 equals 14, which we know is true. So the answer is checked, and the answer is x equals 48. All right, now let's take a look at example 2. All right, step 1, isolate the radical. So to do that, we're going to add 15 to both sides. So that's 5 cube root of 4x plus 3 equals 15. And then we're going to divide both sides by 5. So that's the cube root of 4x plus 3 equals 3. Now, step 2, raise both sides of the equation to the power equal to the index of the radical. So we're going to raise both sides by 3. Well, this becomes to the power of 1, so you get 4x plus 3. 3 cubed is 27. And then step 3, solve for the variable. So we're going to subtract 3 from both sides. So you get 4x equals 24. And then divide both sides by 4, x equals 6. Now you might notice I'm trying to keep my work on the left, so I have space to check on the right. All right, so to check, you substitute x in, so you get 5 times the cube root of 4 times 6 plus 3 minus 15 equals 0. Well, that's 5 times the cube root of 4 times 6 is 24 plus 3 is 27 minus 15 equals 0. Well, the cube root of 27 is 3. 3 times 5 is 15. So 15 minus 15 equals 0. So that is true. So it's checked. And we can say that x equals 6 is the solution. All right, let's take a look at example 3. All right, so step 1, isolate the radical. It's as isolated as it can be, okay, because there's nothing really you can do to 5. If you divide by 5 here, then that has a 1/5. So that's as isolated as it can be. So step 2, raise both sides of the equation to the power equal to the index of the radical. If there's no index written, we assume it's 2. So we're going to raise both sides by the power of 2. But before we move on, we're going to add some lines to help with our organization with our Wildcat Blue Flexi Ruler. All right, so as I showed you in example 1, when you raise an index by the same power, or by the same number of power here, this becomes the power of 1. So that's 35 equals, now when you square something, you multiply it by itself twice. So that's, this squared is 5 times the square root of x plus 2 times 5 times the square root of x plus 2. So then that's 35 equals 5 times 5 is 25. The square root of x plus 2 is x plus 2 to the 1 half. And the square root of x plus 2 is x plus 2 to the 1 half. Now, we know from our radical expressions and rational exponents notes that when you multiply here, you add exponents. So 1 half plus 1 half is 1. So that becomes x plus 2 to the power of 1, which is just x plus 2. So that's 35 equals 25 times x plus 2. So now you distribute 25, so you get 35 equals 25x plus 50. All right, so we're running low on space, but I think maybe if I adjust this line a little bit better and add one more line, maybe we can show an extra step. All right, so we subtract 50 from both sides, you get negative 15 equals 25x, and you divide by 25 by both sides, you get negative 15 divided by 25. So x equals negative 15 divided by 25. And I put the x on the left because we need to reduce this. Okay, it's easier to reduce when you're moving right. So these are both divisible by 5. So 5 goes in negative 15 3 times and 25 4 times. So this reduces to be negative 3/4. Oh, negative 3/5. Almost made a mistake because 5 times 5 is 25. Either way, negative 15 divided by 25 reduces to be negative 3/5. Now, try to keep the work on the right, but didn't get all the way. But I think the check, we just need about this much space. So we can do our check right here. All right, so you substitute negative 3/5 in for x. So then square root of 35 equals 5 times the square root of negative 3/5 plus 2, which that becomes the square root of square root of 35 equals 5 times negative 3/5 plus 2 is 7/5, which if you put this in a calculator, you'll see that they both equal the same number, so this checks. So x equals negative 3/5 is the solution. All right, let's look at example 4. Okay, step 1, isolate the radical as it's isolated as can be. And in fact, actually, I just noticed that 3 and 4 are almost similar problems. So why don't you pause the video at this point, try example 4, and then get to a point where you think you have the answer or you get stuck, and then press play and start watching as I go through it and see if I can fill you in or I can verify that your work is correct. All right, either way, I assume now you've unpaused and let's go through the problem. So we're going to, step 2, raise both sides of the equation to the power equal to the index of the radical. Index is 3, so we're going to raise both sides by 3. This becomes to the power of 1, so you get x plus 6 equals, now cubed, you're multiplying this by itself 3 times, so that's 2. And I'm going to write square root of x minus 1 as x minus 1 to the 1 half times 2 times x minus 1 to the 1 half times 2 times x minus 1 to the 1 half. And I'm hoping you see, by drawing the lines, it helps you keep the 1/2 organized, or the square roots and things like that, okay? All right, so now we just have x plus 6, so nothing we can do with it yet. 2 times 2 is 4, times 2 is 8. When you multiply exponents, you add them. So 1/2 plus 1/2. Oh, no, not 1/2. Those are 1/3. Whoa. And I made a mistake, but I want you to understand how I caught myself is I knew that 1/2 plus 1/2 plus not 1/2 wasn't going to be 1. And I know when I multiply by the index, it's almost always going to become the power of 1. So now 1/3 plus 1/3 plus 1/3 is 3/3. So this becomes the power of 1. So then that's just x minus 1. Plus I looked up and I saw the cubed. And so I knew that 2 was wrong. All right. So now you distribute the 8, so you get x plus 6 equals 8x minus 8. All right, so we're going to subtract 1x from both sides, and we're going to add 8 to both sides. Those cancel, you get 14 equals 7x. Those cancel. Now you divide both sides by 7, so x equals 2. Now, by the way, if I ever make a mistake, that's a great opportunity to just, once I make the mistake, stop in that example and then ask me to go over that again in class, and I can fill in and start from there, okay? All right, so now let's go into step 4, check. And I haven't said it, but when you do check, you actually have to write the word check. So I know that when I see the word check, I'm looking for your check work, okay? All right, so we're going to substitute 2 in. So that's the cube root of 2 plus 6 equals the cube root of 2 minus 1. Well, 6 plus 2 is 8. The cube root of 8 is 2. 2 minus 1 is 1. The cube root of 1 is, and there should be a 2 right here, 2 times. So 2 minus 1 is 1. Cube root of 1 is 1 times 2 is 2. So it checks. So x equals 2 is the solution. All right. Now let's look at example 5. And again, we're going to add lines. All right, example 5. So isolate the radical. Radical is isolated. Now we're going to raise both sides of the equation to the power equal to the index of the radical. So index is 2. So we're going to raise both sides by 2. This becomes the power of 1, so you get x plus 18. And then x minus 2 squared is x minus 2 times x minus 2. Now this is why when I started, I multiplied these with a box, but then I said we're going to move into FOIL. It's not practical to draw a box right here. So if you need to on the separate sheet of paper, you can. But in essence, we're going to FOIL here, okay? So that's x plus 18 equals 1x times 1x is 1x squared. 1x times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. So then you get x plus 18 equals 1x squared minus 4x plus 4. Now, in order to factor, we need to move everything to one side. So I'm going to subtract 1x from both sides, and I'm going to subtract 18 from both sides. Those both cancel, leave it with 0. You're left with 1x squared. Now that's negative 4x minus 1x is negative 5x. And then 4 minus 18 is negative 14. All right, so now we need a factor. We know x and x. Now we need to find all the combinations that give us negative 14. So we know that 1 times negative 14 is negative 14, but 1 minus 14 is negative 13. That doesn't work. 2 times negative 7, and I guess I can write these down. 1 times negative 14 doesn't work. 2 times negative 7. 2 times negative 7 is negative 14. 2 minus 7 is negative 5, so we know our factors are x plus 2, x minus 7. So we set those equal to 0, so x plus 2 equal to 0, and x minus 7 equal to 0. So we subtract 2x equals negative 2, add 7x equals 7. All right, and we're going to have to use this little space we have right here to check. Okay, so we substitute negative 2 in, so we get the square root of negative 2 plus 18 equals negative 2 minus 2. Well, that's the square root of 16, which is 4. 4 does not equal negative 4, so that answer doesn't work. So x equals negative 2 is not a solution. Now we try 7. Square root of 7 plus 18 is 7 minus 2. That's 25. Square root of 25 is 5. 7 minus 2 is 5, so this checks. So x equals 7 is your solution. All right, now you'll notice that example 5 and 6 are the same. So you might pause video, try example 6, and then if you get stuck or you finish and you want to check as I go over it, then you want to unpause. All right, so example 6. We've isolated a radical. This done. Step 2, raise both sides of the equation to the power equal to the index of the radical. So the index is 2, so we're going to raise both sides by 2. So this becomes the power of 1, so you get 2x plus 14 equals x plus 3 times x plus 3. Okay, so then that's 2x plus 14 equals x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Now we need to subtract 2x from both sides and 14 from both sides. Those cancel. You're left with 0 equals 1x squared. 3x plus 3x is 6x. Minus 2x is 4x. And then 9 minus 14 is negative 5. So we need to find all the factors that give you negative 5 and 4. So 1 times negative 5 multiplies to give you negative 5, but adds to be negative 4. 2 doesn't work, 3 doesn't work, 4 doesn't work. 5 times negative 1 gives you negative 5. 5 minus 1 is 4. So our factors are x plus 5 and x minus 1. Now, the step here where I actually set them equal to 0, you don't actually have to do this step. You can know that this equal to 0, this equal to 0. So that equals x equals negative 5 and x equals 1. And then we check. All right, so the check, we substitute negative 5 in, so we get the square root of 2 times negative 5 plus 14 equals negative 5 plus 3. Well, that's the square root of 4 is positive 2 does not equal negative 2, so that doesn't work. So we know that x equals negative 5 is not a solution. Now we try 1. The square root of 2 times 1 plus 14 equals 2 plus, 1 plus 3. So that's the square root of 16 is 4. 1 plus 3 is 4. So this checks. So our answer is x equals 1. All right. So now let's look at example 7. And again, we're going to add lines. All right, so here it says isolate the radical, we did, and then it says raise both sides of the equation to the power of the equal to the index of the radical. So the index is 1/3, so we're going to raise both sides by 3. Now here, you multiply, and that looks like a 2, but it's actually a 3. So when you actually have this, we know from our radical expressions, rational exponents, lesson that we know we multiply here. So 1/3 times 3 is 3/3, so that becomes 3 divided by 3, which is 1. So this becomes x plus 5 to the power of 1, which is just x plus 5, equals 3 cubed is 27. Subtract 5 from both sides, x equals 22. Then you check your work. So then we know that's 22 plus 5 to the power of 1/3 equals 3. We can rewrite this as the cube root of 27 equals 3. Well, the cube root of 27 is 3. 3 equals 3, so that checks. All right, example 8. Same thing. But in this case, we're going to square both sides. So that's x squared. 2 times 1/2 is 2 divided by 2, which is 1. So that's just equal to x plus 12. Well, there's a bell, which means we probably need to finish up. So let's finish this up. All right. So we need to actually, and I actually need to, I'm going to write this like this actually, because I need to show you that we're going to subtract 1x from both sides and subtract 12 from both sides. Cancels, cancels, you get 1x squared minus 1x minus 12 equals 0. And we did that because we need a factor. We know x and x, and then we need to find the factors of negative 12. So 1 times negative 12, which gives us negative 11, doesn't work. 2 times negative 6 gives us negative 4, doesn't work. 3 times negative 4, which gives us negative 1. So we have x plus 3, x minus 4. Set x plus 3 equal to 0, x minus 4 equal to 0. So x equals negative 3 and x equals 4. All right, and then we need to check. So to check, we know that we have negative 3 squared equals negative 3 plus 12 to the 1/2. Well, that's 9, that becomes negative 3 plus 12 is 9. The square root of 9 is 3. This doesn't work, so now we try 4. 4 squared equals 4 plus 12 to the 1/2, which we know is the square root of 16. And actually, wait a second, that's not right. That should just be negative 3. Okay, not the squared. And the mistake I made was I put the squared there and I wasn't looking at it. I should have just looked at that. But either way, negative 3 does not equal the square root of 9, which is 3. And then the square root of 16 is 4, so this checks. So the answer is x equals 4. Whew. Wow. There you go. And remember, you have 2 routes at this point. Route 1, you wait to class to go over the examples you had questions over, or route 2, start working on the assignments. So with that, have a wonderful Wildcat